Forget what you think you know about Yellowstone. Beneath its stunning beauty lies a hidden world, a pulsating immense power that dictates every eruption and seismic rumble. Join us as we journey into the Earth's enigmatic depths, revealing the incredible secrets that have remained buried until now. Hey, buddy! Imagine standing there in Yellowstone National Park watching Old Faithful shoot sky high like clockwork, or soaking in the steam from those colorful hot springs that look like something out of a sci-fi movie. It's also mesmerizing on the surface, those bubbling pools, the wildlife roaming free, the vast meadows dotted with bison. But what if I told you that's just the tip of the iceberg, or more accurately, the thin crust over a colossal beast lurking below? We're talking about Yellowstone's hidden subsurface, a world of molten rock, intense heat, and geological drama that's been shaping this place for millions of years. Let's dive in together, like two explorers peering into the abyss and uncover what really lies beneath this iconic landscape. Picture this, a panoramic view of Yellowstone's rolling hills, geysers erupting in the distance, maybe a herd of elk grazing peacefully. Then, bam! We zoom in, slicing through the earth like an X-ray. Layer by layer, we peel back the soil, the rock, the crust, until we're staring at the fiery heart of it all. The question hangs in the air. What truly lies beneath Yellowstone's iconic beauty? Well, my friend, it's not just dirt and stones, it's a supervolcano, a massive active system that's way more than the doomsday headlines make it out to be. Sure, it could pack a punch if it ever fully let loose, but let's focus on the awe-inspiring side. This thing is a living, breathing engine of the Earth, fueling everything we love about the park. First off, let's wrap our heads around the scale. Yellowstone isn't your average volcano with a neat cone and a lava flow. Nope, it's a supervolcano, which means its eruptions can be thousands of times more powerful than, say, Mount St. Helens. At its core is the Yellowstone Caldera, a gigantic depression formed by ancient blasts. Think a bowl-shaped scar stretching about 30 by 45 miles across Wyoming, Idaho, and Montana. That's bigger than some cities, and beneath that, not one, but multiple reservoirs of magma, that super-hot, semi-molten rock that's the stuff of planetary creation. Scientists have been piecing this puzzle together with seismic waves, electromagnetic surveys, and all sorts of high-tech wizardry. From what we've learned, thanks to studies from places like the University of Utah and the USGS, there's an upper magma chamber sitting roughly 3 to 8 miles below the surface. This one's filled with rhyolitic magma, a thick, sticky type that's high in silica and gases, making it explosive when it decides to move. Picture it as a gigantic frying pan of bubbling goo, spanning up to 55 miles by 30 miles and holding around 2,500 cubic miles of material. That's enough to fill the Grand Canyon multiple times over. But wait, there's more. Deeper down, around 12 to 28 miles beneath, lies an even bigger reservoir of basaltic magma, the more fluid, primitive stuff that comes straight from the Earth's mantle. This lower chamber is massive, estimated at over 10,000 cubic miles, and it's connected to the upper one like a fuel tank feeding an engine. Now, how does all this hidden power show up on the surface? It's all about the heat, my friend. That magma down there is scorching, temperatures hitting 2,500 degrees Fahrenheit or more, and it warms up the groundwater percolating through the rocks above. The result? Those famous hydrothermal features. Geysers like Old Faithful, which erupts because pressure builds up in superheated water until it blasts out. Hot springs painted in vibrant hues from heat-loving bacteria, mud pots bubbling like witches' cauldrons, and fumaroles hissing steam into the air. Without this subsurface furnace, Yellowstone would just be another pretty forest. Instead, it's a dynamic wonderland where the Earth is constantly recycling itself, pushing up minerals, reshaping the land, and even influencing the ecosystem. Those warm waters create microhabitats for unique life forms that thrive in extremes. But here's where it gets even cooler. Recent discoveries are flipping the script on what we thought we knew. Just this year, in 2025, researchers using advanced imaging techniques found a magma cap, or layer of supercritical fluids. Think super hot, super dense gases, and partial melts, sitting right between the main magma reservoir and the surface. This cap acts like a pressure valve, venting built-up energy and actually reducing the chances of a massive eruption anytime soon. It's like the volcano has its own built-in safety mechanism. Studies from Rice University and others show this cap is about 3.8 kilometers thick in places, and it's breathing, expanding and contracting with the magma below. No wonder the ground in Yellowstone sometimes rises and falls by inches over years. It's alive down there. Let's rewind a bit and talk about how our understanding of this beast has evolved, because it's a story of human curiosity pushing boundaries. Back in the 1800s, when Yellowstone became the world's first national park in 1872, explorers like Ferdinand Hayden marveled at the geysers but didn't fully grasp the volcanic connection. They thought maybe it was just hot springs from underground steam, perhaps linked to separate volcanoes. It wasn't until the mid-20th century that geologists started connecting the dots. In the 1960s, folks like Robert Christensen from the USGS mapped out the caldera for the first time, realizing those flat plains were the remnants of a collapsed supervolcano from eruptions 2.1 million, 1.3 million, and 640,000 years ago. Each blast was cataclysmic. The biggest one spewed over 2,500 cubic kilometers of ash, blanketing half the continent and altering global climate. By the 1970s and 80s, the hotspot theory took hold. Yellowstone sits atop a mantle plume, a hot upwelling from deep in the earth like a blowtorch melting the crust as the North American plate drifts over it. This explains the chain of ancient calderas stretching southwest across Idaho, marking the hotspot's path over 17 million years. But our view was still fuzzy. We knew there was magma, but not the details. Fast forward to the 2010s, and seismic tomography, using earthquake waves like a CT scan, revealed that upper chamber. Then, in 2015, a bombshell. University of Utah scientists imaged the deeper basaltic reservoir, showing how basalt from below mixes with crustal rocks to create the explosive rhyolite above. It was like discovering a hidden basement in a house you thought you knew. And now, with electromagnetic imaging measuring how electricity flows through rocks to spot melts, and even satellite data tracking ground deformation, we're seeing Yellowstone in 3D like never before. A 2025 study in Science detailed how the magma is on the move, with the upper chambers holding 240 to 300 cubic miles of melt and the whole system interconnected. We've learned that hydrothermal explosions, those sudden steam blasts that carve craters like the recent one under Yellowstone Lake, are more common threats than full eruptions. The last lava flow was 70,000 years ago, and while the volcano is active, it's slumbering peacefully for now. This isn't just academic stuff. It changes how we see our planet. Yellowstone reminds us that Earth is a restless giant, with forces from the core bubbling up to create beauty and chaos. It's a window into plate tectonics, mantle dynamics, and even the origins of life. Those extreme environments mimic what might have sparked biology billions of years ago. Plus, monitoring it helps us predict hazards, not just here but at other hotspots like Hawaii or Iceland. So next time you're gazing at a geyser or hiking those trails, remember the hidden world below. It's a testament to nature's raw power, a colossal system that's been ticking away for eons, shaping the landscape we cherish. We've come so far in unveiling these secrets, from early guesses to cutting-edge scans, and who knows what we'll discover next. The Earth keeps surprising us, and Yellowstone? It's the ultimate thrill ride, hidden in plain sight. Let's keep exploring, my friend. There's always more beneath the surface.